This is, again, 2.6 day 1, and we're talking about rational functions, characteristics of rational functions. Before we talked about vertical and horizontal asymptotes. We're going to add a couple into the mix for this one, that is X-intercepts and Y-intercept. So the way we find these in any case is we're going to make the numerator equal to 0 for the X-intercepts. So we'll be looking at that in this particular example here, and then for the y-intercept we're just going to plug 0 in for any of the x values that you see. So we'll do that with this example, and I'll show you how that all works. We're going to start with this example of g of x equals x plus 2 over x squared plus 2x minus 3. Now I always kind of like to just start with the graph. So what I'm going to do right off the bat is I'm just going to put this in my graphing calculator, as you'll see right here. Make sure that you're using parentheses around the numerator and denominator, otherwise the calculator will interpret it differently. And so I'm going to graph that. This is my standard window. It's kind of weird there. It's got some lines connecting it. It's just a calculator error on my calculator here. But I'm going to change it to zoom decimal in this case because it looks a little bit better. Even though the lines don't continue upward or downward, they're supposed to, but this is just a little bit better representation of what we have. And so this should help as far as getting some of my characteristics. All right, now let's look at the equation itself. We've got x plus 2 over x squared plus 2x plus minus 3. Now, I would really recommend in this case that we factor anything that's possible first. So x plus 2 on the top stays as it is. On the bottom, though, we have this quadratic, and we can factor that into x minus 1 and x plus 3. Because the negative 1 and the 3 multiply to negative 3. Negative 1 plus 3 gives us 2. So just a little review of our factoring skills there. So what we've got now is a factored form of this, and we can find some different things with this. So what we just looked at was that x-intercepts are what makes the numerator equal to 0. So I got to think about, looking right here, what value makes this quantity up on top equal to 0. Now why is that the case? It's because, well, if we do anything, 0 divided by anything is just 0. So when the x-intercept is when the numerator is 0, then that makes the y value 0 as well. So in this case it's negative 2. We don't have to put that in equation form. That is just a value. The y-intercept, that one, all we have to do actually is plug 0 in for each of these x's, as it mentions right here, and this works for basically any equation that you can ever think of. So plug 0 in for all these x's. If I put 0 in here, 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 what I'm left with is just 2 over negative 3, which we can put the negative anywhere. 2 over 3 would be our y-intercept in this case. So that's just plugging some values in, plugging the zeros in for all the x's and seeing what's left over in the fraction. Vertical asymptotes. We have what makes the denominator 0 in general. Again, we do need to check with the graph. It does look like we have two vertical asymptotes here, but it's going to be x equals, make it in equation form, x equals 1 and x equals negative 3. Those are going to be our two vertical asymptotes because there are two factors on the bottom. Horizontal asymptote, remember that is going back to our three different cases: top heavy, bottom heavy, or equal degree. In this case, notice that we have x to the first and x over x squared, which means that this is bottom heavy, and so there's only one option here, and that's y equals 0 as the horizontal asymptote. Now, once we do this, we look at domain and range, and we've talked about domain before in a previous chapter where we said we're looking for the red flags. We're looking for square roots, or we're looking for divide by 0. In this case, we have divide by 0, and we've already talked about the vertical asymptotes. These generally go right along with the domain in our rational functions. And so the restrictions here would be, it looks like that x cannot equal 1 and negative 3. Now, when we do domain and range, again, I'm looking for interval notation, and so we put those into, we could graph that, we could just have those holes in the number line if you wanted to get a visual of that. we have -3 and +1, and so those holes exist there. If we're going to get this in interval notation, then it would be -infinity to -3. Okay, we have a breaking point there. It's a hole. Then we connect it. -3 to 1 is our second piece, and then finally our last piece starts back at 1, goes to infinity. So that's going to be our domain in this case, and you can always go to your graph and verify that. As you can see here, we have a break at each of those asymptotes. Then range generally goes along with our the horizontal asymptote, but you'll notice in this case we're looking at a problem like this, and so I've entered it in there. It's in my original form, and you'll notice that this middle one actually goes through the entire thing. And so while you would think, yeah, there is a break here, there's a horizontal asymptote, this one actually hits everything from bottom to top. And so in this case, we are going to say that the range is negative to positive infinity. Again, looking at the graph is the best way to determine range on these, but check out the graph, see if there's any part that has any breaks or gaps. But in this case, it goes from all the way from negative to positive infinity.